Greetings. My name is Wesley Straub, Marketing Director here at Repligen, and it is my great pleasure to welcome you to the second episode of the Repligen 2021 webinar series. Um, During these webinar series, we like to take about 15 minutes and bring in one of our technical experts to provide a relatively high level description of one of our newest technology solutions or applications. Um, in the first episode, we covered the new NGL spike protein um, COVID affinity resin purification used to purify protein-based COVID vaccines. In this second episode, we shift upstream to the bioreactor and a lot earlier in development into the lab setting with an intensification device for the bioreactor. And we're really lucky and very fortunate to have Earl Pineda present this webinar to us today. Earl's been with the technology for over 10 years, and he works directly with customers at a technical level. And that combination of experience and technical know-how from really allows him to cover the breadth of not just the mechanics of how it works and the impact and all the different applications, but what it can really mean to you and your process and your facility. So we're really, really fortunate and welcome Earl to this second session. Um, and the future one, just to touch base before we shift over to Earl, basically our next episode will broadcast on May 27th, and that will cover. We'll go back to chromatography where we talk about use of the Opus robocolumns for purification, rapid purification development on a very small scale to accelerate process development of downstream chromatography applications, right? So with that introduction, just like to turn it over to Earl. If you have any questions during the presentation, you don't have to wait to the end to ask it. There's a Q&A panel. You're welcome to enter a question. We will field the questions at the very end together with Earl. So don't hold back. It's great to see the questions live. It's very self-explanatory. So with that, I'm going to turn it over to Earl for the presentation. We'll see you at the end for some Q&A.
Hey, Wes, thanks for that nice introduction. To the audience, wherever you are, good morning, good afternoon, or good evening. I'm Earl Pineda, and I'll be giving you this webinar today. So the title of this webinar is Modernized Scale-Down Intensification for Faster Advancement to Manufacturing. Now, the key word here is modernized, specifically the evolution and modernization of our ATF controller. And the other keyword is scaled down, basically the extension of our ATF device range, to which we will introduce the new smaller format ATF1. But first, let me start off with this overview slide of some of our flagship product lines that you see pictured here. Over the past 5 years or so, Repligen has positioned itself as a company that focuses on innovative bioprocess tools, not your typical commodity products that you might expect from our bigger competitors, but more niche bioprocess tools that have been game changers in our industry, such as the XL-ATF system, which will be the focus of today's talk, but also products like Opus, meaning open platform user specified. These are ready to use pre-packed columns, basically removing hardware purchase and qualification lead times and reducing costs in the end. Our cross-flow TFF systems, these are our most configurable TFF system in the industry today, supporting both our hollow fiber filters as well as our flat sheet cassettes. Then, of course, our Tangenix flat sheet cassettes. This is a true single-use flat sheet membrane design with engineering that allows a higher flux and a higher recovery, and at a significantly lower cost. And finally, our slope spectroscopy products. These are both at-line and inline slope spectroscopy based on variable path lengths. So it enables concentration measurements without dilution, thereby reducing hands-on time and deviations. So for the agenda, it'll be pretty simple with three parts. First, I'll give an overview of some of the key benefits of the XL-ATF technology in process intensification from PD up to manufacturing. Then I'll focus on our new product releases, specifically the new XL Lab controller, as well as the new XL ATF1 device. And lastly, I'll show a little bit on the new Excel software and its improved functionality. Here's a nice illustration of the Excel ATF technology and how it can be used to intensify your process. When we say more cells faster, means to say, it has been used, to produce more cells, thereby enabling higher seeding of the next bioreactor, for example, and more product faster, meaning to say with these higher VCVs through perfusion, you really can achieve higher productivity. And this is true across multiple therapeutic types, whether it be mAbs, viruses or VLPs, complex recombinant proteins, etc. And on the bottom here, you see a lot of nice buzzwords often used to describe ATF benefits. But these benefits really have been proven over the years since the ATFs existed. As we've seen in industry time and time again, the ATF can be used to achieve increased throughput in terms of molecules or even entire programs, or increase product yield, meaning more product per batch, advancing programs faster by allowing more batches within the same facility, or all of the above in some cases, all of which greatly benefit the business case. After all, management is always looking for this higher return on investment. So process intensification using the ATF in your process enables these smaller bioreactors, these smaller, flexible, single-use type facilities, and therefore lower cost, lower risk, and potentially faster results with such process intensification. But the last point here is what I really want to highlight today, and this is the new XL Lab controller. It has been engineered for simplicity, precision pumping, more process data, and an enhanced user experience. This slide illustrates the full scalability of the XL ATF system, from bench scale process development as low as 500 mils, working volume, potentially even less, all the way up to manufacturing scale, up to 5,000 liters, which really is our current largest bioreactor using the XL ATF, and everything in between, including clinical manufacturing using pilot scale systems like the ATF6, and MSAT activities, used for troubleshooting or commercial rework. The XL Lab controller itself is specifically designed for process development and MSAT, as you can see in the photos above, where particular focus is on these reliable scale down models to get the best predictability of performance at the large manufacturing scale. The lab scale devices, like the ATF1 and ATF2, provide linear scale up parameters, such as flux and shear. The precision and additional functionality of this new controller really is meant to provide the best results, whether doing process optimization, scale up, or commercial rework. Here we have the current family of ATF sizes and some of their specifications below it. Many of you may be familiar with the XL ATF2, 4, 6, and 10, but now we introduce the new XL ATF1, which enables a development at even lower working volumes, less than 2 liters, therefore accelerating DOE and saving media with each run. The ATF1, as you can see, is available in a single-use format only, currently with 0.2 micron PES filters, as this is the most commonly used pore size for a variety of applications in the industry. Also notice that the filter length is 60 centimeters, so this is the same as ATF2, ATF6, and ATF10. And this is for the main purpose of linear scalability, to enable this reliable scale down model down to at least 500 mils and possibly even less. Each ATF device here is controlled by a controller. And of course, each controller supports a number of ATF devices. The XL Lab itself will be replacing the previous C24 controller. Therefore, it's still supporting the XL ATF2 and ATF4, but it is the only controller to support the new XL ATF1 format. And the C410 here still supports ATF4, 6, and ATF10. This slide shows the components of the XL Lab system. It's really a complete solution, and all the components come as a validated system. Notice that number 1 here is a flow sensor. The XL Lab is based on actual measurement of flow using the sensor, therefore true flow-based control, unlike the C24, which relied more on a time-based algorithm. That translates to higher accuracy with the XL Lab over a broader range of cell culture conditions. The number two is, of course, our XL ATF device. In this case, what's pictured is the new ATF1 format, and it can be equipped with an integrated permeate pressure sensors, and I'll go through that a little bit later in the webinar. Number three is the XL Lab controller. It's a controller itself, but it also has a tablet-based HMI, which can be attached magnetically to the controller, as you can see in the picture here, or it can be on a clamp stand. And part four here is what we call a SAPA, Supply Air Protection Assembly, which has all the parts necessary to properly condition the air utilities required for this new controller, such as down regulation of specific pressure. There's an air filter to prevent particles from damaging the pneumatics, pressure relief for added safety, and a manifold to connect multiple ATF XL Lab controllers. And lastly, parts 5 and 6 make up the vacuum side requirements, a strong dry vacuum pump, and its associated manifold. Here's a summary of key improvements of the new XL Lab controller over the legacy C24. First of all, the new XL Lab controller is available in a dual channel configuration, meaning one controller can control two different ATF devices. You can see that in one configuration, two devices are connected to separate bioreactors. The ATFs connected can be the same, for example, both being ATF1s or both being ATF2s, or they can be different, one being ATF1 or one being ATF2 or 4. So you can really mix and match depending on your bioreactor size and working volume. The configuration below that shows two ATF devices connected to the same bioreactor. This can be helpful when mimicking a process that requires two ATFs at large scale, for example. The XL Lab controller has a tablet-based HMI, as I've said earlier. This is detachable, so you have a variety of mounting options. A lot of work has been put to make the interface simple and intuitive, therefore more user-friendly. A more modern approach compared to the old C24 human user interface. We are promoting a complete solution and this concept of a fully integrated system that makes setup and running a process much faster and more simple. And finally, to the right, I wanted to talk a little bit more about this additional new functionality that's unavailable with the current C24. This flow-based control actually allows higher precision across a variety of cell culture conditions, particularly more challenging viscosities. I'm going to talk more about this later, but that's a very important point. Second, here you can see the option of permeate pressure measurement, basically to enable real-time monitoring of filter performance over the course of the run. And you can configure alarms, which can be used based on permeate pressure. For example, an alarm indicating filter fouling. So these are great improvements to this new controller. As I've said before, the new XL Lab controller is based on an improved control platform. Actual flow is measured using the state-of-the-art flow sensor, and therefore inherently more accurate than the old C24 controller, which relied on a time-based algorithm to deduce flow rates. With certain processes that have challenging cell culture conditions, such as high viscosities, maintaining accurate ATF flow rates can be challenging, and has been so with the C24. But as you can see from the data on the right, the XL Lab is able to maintain consistent flow rates with increasing viscosity in a linear fashion and with high precision. Basically, the overlapping lines indicate a high correlation between theoretical and observed flow rates. To the left, it's kind of a nice schematic to show newly engineered supporting hardware and control loop, the primary flow sensor and internal valving that are connected by a sophisticated control logic feedback loop. So, this controller really gives the confidence of accurate flow rates and the scale up that's really based on that flow rate. Now, like I said, I'm going to talk more about pressure monitoring. This is a really important data point. We call this permeate pressure P3, and this enables real-time filter status or fouling monitoring. Single-use ATF devices can be ordered with these integrated permeate pressure sensors, as you can see here blown up, it's this yellow part of the device. The stainless steel ATF devices also have an additional option in the form of a P3 pressure sensor kit. So you can, do the same type of experiments, whether it be single use or stainless steel. Illustrated here on the right, you can see the P3 pressure trend. It can be visualized on the actual HMI of the controller. As the filter membrane starts to exhibit fouling, P3 will begin to drop. And understanding this can really help with filter performance characterization over a variety of cell culture conditions. And knowing the actual point of filter fouling is an important data point. It can be used to trigger alarms that can prompt the user to swap out that filter, should that be part of your process. So understanding of the P3 trend allows the user to really challenge the filter and extend processes until end of filter life. And scale down runs with this knowledge can be used for risk mitigation at production scale. This new XCell Lab controller is highly configurable with different setup options within your laboratory space. It's designed to promote flexibility and throughput to really maximize facility utilization. Each SAPA, as you can see highlighted in blue, and vacuum manifold supports up to 4 XCell Lab controllers, and each of these controllers themselves can support up to 2 ATF devices. Both devices can be on the same bioreactor or attached to separate bioreactors. You can really mix and match the different sizes of ATF depending on the bioreactor size and the working volume that you're dealing with. The XCell controller supports devices ATF 1, 2, and 4. So it's really spanning bioreactor working volumes from about 500 mils up to 50 liters. This is really a huge range for a single controller. The XCell Lab has a tablet-based HMI with an interface that's been designed with, really with the user in mind, to be simple, to be intuitive, and with considerations on future updates to the controller should that happen. It is a touch screen, so it doesn't require a keyboard or mouse. So the interactive elements of this interface, like the buttons and input fields, are designed for a finger and not a tiny mouse pointer. The HMI kit includes a splash-proof case, pictured here, which is easily mountable on the controller itself, or it can be clamped on a shelf. You can see that on the top right. And this can be adjusted really to meet your space and ergonomic needs. Also shown here are specifications for the footprint of this new controller. It's about 30 by 40, and controlling 2 devices, it really reduces the footprint compared to having 2 C24 controllers. The software interface was designed in a minimalistic type layout, really to keep it simple and easy to use. Colors and formats are consistent for fast familiarization. Identifying alarm, for example, is made easy as they're visually associated with each component, as you can see here by the red border. On this example of the main screen on the top left, you see 2 ATF devices connected to the same bioreactor. Notice that the ATF images are the actual equipment being used. In this case, you know that you're using 2 single-use ATF2s. Here, it's kind of hard to see, but pump status actually shows an accurate representation of the diaphragm position during the diaphragm stroke. These strokes can be independent or synchronized in either of 2 modes. So if it's an in-phase sync mode, the diaphragms of both ATFs are moving up and down simultaneously. If it's an out-of-phase sync mode, the diaphragms are moving in opposite directions. And this mode can be useful, keeping constant working volume if you're using 2 ATFs, for example. The top menu on this interface is always visible, while submenu items appear for more detailed setup and configuration. Note that, here you can see a lot of different ATF devices and part numbers. These are all automatically built in, programmed into the controller, and it also includes more specifications for that device that you've chosen. And just a few additional points about the software. The HMI and security features can be configured to suit your needs, such as units, date and time formats, log out and restart settings. The actual operating system is based on Windows, so you have Windows level security with pre-programmed default users, ability to set username and passwords to internal requirements, and access levels are assigned by Windows level users. This slide, it's really just to make the point that all of the nice hardware and software I just talked about and come inside this new box is only half the offering. Repligen provides exceptional support from our technical field experts, FAS, field service engineers, the FSEs, which is really a great after purchase added value. So the field service typically helps with installation, service, and maintenance, and the FALs, the field application scientists, provide training on proper use of equipment, as well as free consultation from cell culture to optimization, scale up, even down to downstream integration, supporting validation and beyond. Here is a little bit more detailed information about the newly launched XCell ATF1. It is in a single-use format only, so no assembly or autoclaving really needed. It's simply plug and play by easy connection to the bioreactor, either by welding or sterile aseptic quick or ready-made, or I'm sorry, this is only a aseptic quick connector. The device specifications are integrated into the XCell lab software, making the setup much faster and simpler. You can see that it is available with integrated permeate pressure sensors, again in yellow, for those additional process data points. So, this ATF1 is a natural extension of our ATF device family to support development at, mini scale bioreactors, 0.5 to 2 liters, maybe even less than 0.5 liters, depending on, your specific bioreactor. An important point here is that, with the use of these smaller ATFs and smaller bioreactors, you're really reducing media usage and costs, and these can be significant in perfusion processes. This has been a request for many of our customers over the years, and we're really finally delivering this. The ATF1 filter maintains the same aspect ratio, the 60 centimeter fiber length. That's common with our ATF2, ATF6, and ATF10 systems, and therefore enabling this consistency and scalable parameters. Therefore, even the smallest ATF device can provide reliable flux, shear, and fouling parameters for this type of scale up. So yes, the ATF1 is a true scale down model. This slide just shows that the XCell ATF allows easy connection to any bioreactor. Recently, we've been extending our offering for different connection accessories. The dip tubes, head plate fittings, and various tube sets are all off the shelf. So I guess this means shorter lead times. Since the ATF devices are available in both single-use and stainless steel formats, flexibility in terms of connectivity is really important. And our accessories, our new accessories, really tries to make this as easy as possible. So this is going to be my final slide of this presentation. The slide really shows the commercial success of the XCell ATF over the past 20 years, which really boils down to its significantly better performance compared to other cell retention devices, such as centrifuges, self-settlers, acoustic devices, or even other filtration techniques using the TFF, for example. Based on our latest count, more than 4,000 XCell devices are in use in over 400 sites globally. At least 40 of these are commercial processes across 9 different countries, and greater than 30 processes are in late phase, and hundreds more in early phase and preclinical. Here you can see 2 pie charts at the bottom. The left is ATF adoption by molecule, and it basically shows the majority of these have been for mAbs and recombinant proteins historically, but gene therapy is a very hot field right now, still a bit new in terms of process intensification. So we really foresee the ATF helping these type of gene therapy applications moving forward, as it has done historically with mAbs and recombinant proteins. The pie chart on the bottom right is ATF adoption by application. So the ATF has been predominantly used for N bioreactor perfusion, more recently N-1 intensification, followed by concentrated fed batch type applications and other smaller applications listed here. Now, the ATF technology has been proven successful time and time again, as you can see with this data. It has been the gold standard cell retention device since its inception. But I really want to summarize and point out that Repligen continues to invest in making better controllers like the XL Lab that I talked about today. It continues to expand the ATF product line with new formats like the XL ATF1. And finally, Repligen as a company, we continue to innovate with strategic bioprocess tools for your process intensification goals. And with that, that was my last slide. I want to thank you guys all for your attention today. And I guess we're going to be having our Q&A session. So I'm going to hand it back to Wes and look forward to hearing your questions soon.
Alrighty, thanks, Earl. So it turns out we have about 11, somewhere about 11 or 12 questions that came in over the course of the presentation, right? So I'm going to try and do this from the nuts and bolts in the beginning and then bring it forward to the applications rather than take them in chronological. Earl, one of the questions that came in was are standard house vacuum and positive air pressure lines sufficient to run the system?
Yeah, so hear me okay? Yep. So
Yep.
positive air pressure, unlike the C24, the C410, the requirement is a little bit less on the pressure side. So let's say about 20 psi of pressure, whereas a vacuum side, it's basically the same vacuum pump. I don't recommend house vacuum because either if it is house vacuum, it should be dedicated. Otherwise, we sell a very good vacuum pump for this particular purpose.
Okay, I should do it. Like this one, I think I get is the second ATF device active at the same time. I think that's from like when we show the two devices connected to one bioreactor, whether they're both going at the same time or not at the same time. Yeah.
Yeah, it can be. I mean, if you have two separate bioreactors connected to separate ATFs, yes, you can use both at the same time. If you have two bioreactor or one bioreactor with two ATFs, and you're doing an experiment kind of to mimic, let's say, large scale where you have two ATFs connected to a bioreactor, yes, in that case, the second ATF is active. If you want, you can also just use a single channel for one bioreactor. That's not a problem either.
Yeah. Yeah. But you don't have to have them both active, right? You could have the second one as like a backup or easy switch or something like that.
Exactly. You can activate it later on during the process.
Yeah. I think that's what the question was kind of getting at. And then a little bit on the software side, will the alarm just alert the user or modify, halt the process? And what if I'm not in the lab? I guess when an alarm goes off. Yeah.
Yeah, at this point, it's more of an alert. I have been talking with some customers who would like a specific action based on an alarm, and that's going to be more of a voice of customer at this point. And as we proceed with this new controller over the next few years, we will have software updates. And that's one thing that I am really interested in, is to have an action based on an alarm, especially let's say it's on the weekend and you need to you need to have it do something if there is that a specific alarm. But at this
Yeah,
point,
that's right.
it is just at this point
Just
it's just a notification.
Yeah. Because some of these processes do go for a long time,
Yeah,
like multiple days.
exactly.
Yeah. Gotcha. Kind of sticking with software, can the data be processed offline in different software like Excel or Jump?
Yeah, that's a good question, and it can. There's a way to export it as a CSV file and export onto a USB stick, which you can take into your computer and plot. So you can define certain parameters for what you want to plot.
Okay. Now we're kind of getting into a little bit more of the applications stuff. Can the Excel system be used for, get ready for big acronym, SPTFF or single pass TFF?
Yeah, no. So this Excel system, Excel Lab Controller, is specifically for ATF, and that's the technology of alternating tangential flow. So it's not a downstream product. It's more an upstream product where you use for continuous processing, like perfusion, type processes.
Yep.
So no,
Okay.
I believe the answer would be no. Yeah.
And if you have a 1 liter process, would you prefer an XL ATF1 or 2 device?
I would say XL ATF1 is more of the recommended format for 1 liter. Of course, we do have customers who have used ATF2 for 1 liter with success, but I think it's okay as a proof of feasibility study, but not a true scale down model. You have to do some manipulations to really make it so that the fluxes are the same as you might expect from the large scale. So the reason why we developed the XL ATF1 is specifically for these smaller bioreactor working volumes, less than 2 liters. So no, I would definitely recommend XL ATF1.
Yeah. We got some air. So I totally get the air quotes on this one. This one is there a quote unquote average VCD increase from fed batch? Which we all right. So we all get that different processes, different cell lines. But
I think it's a good question. It's a fair question. Yeah.
It's a fair question. Yeah.
I mean, from my experience and what I see in the field, fed batch max VCDs are going higher and higher. I've seen. I mean, typically they're, I would say, between 10 and 20 million cells per mil, but now I see 30 to 50 million cells per mil. So but perfusion, I would say, is maybe a tenfold increase in that. So, if you want to have a good manufacturing process, I wouldn't say go to the maximum, maybe less than 100 million cells per mil. But some of our customers, get up to 300 million cells per mil in the perfusion process compared to, let's say, the equivalent in the fed batch, which would be maybe 30 million cells per mil. So I would say about 10x even.
Okay. Yeah, that couples with I was going to follow that one with which therapeutic types are compatible with the system or the technology. Again, a good one given that you've been out there for so long.
Yeah, I would say, I've seen everything. It's historically been used for mAbs, recombinant proteins, fusion proteins, vaccines. So a bunch of different viruses, viral-like particles, even some. I wouldn't say some, maybe like 1 or 2 microbial, but it's really not a process that ATF is designed for. I would say it's more mammalian cell culture with really any type of molecule that's being produced by mammalian cells.
Okay. I think I'm not sure like what were the scale down parameters. I think maybe maybe like on the alarm slide somebody was asking, maybe just general, like basically what are some general parameters for a generic process for scale down?
Yeah, so our strategy when we scale up is we want to make sure that the cells really don't know if they're in this ATF2 or an ATF10. So we have to control certain parameters, which includes, for example, the velocity of flow through the fiber, right? So we look at shear. We look at from the performance of the filter, we look at this transmembrane pressure. So we look at backflush to make sure that that filter is going to experience the same type of stress per unit area between the ATF2 and ATF10. We look at the residence time. So how long would the cell be out of the bioreactor itself compared in the small scale and large scale? Although this residence time is less of a concern because the ATF pumping range is so much faster compared to let's say the perfusion rate, right? So it's such a dynamic exchange that you have to really look at the ATF as an extension of that bioreactor.
Yeah. Juliana has a follow-up question on the ATF1 versus 2, right? She says again about the ATF1 versus 2. Totally love the follow-up question. Like, just love sticking with it. The ATF flow range, liters per minute, defined based on the filter. Is it based on the filter area? Because she noted that the LMP range for ATF1 was significantly, LPM for ATF1 was lower than 2.
If you look at the pump size as well as the filter, I would say the ATF1 is about 1/5 of the ATF2. Right, so you can expect the flow range to be about 1/5 of the ATF2 if you're used to the ATF2, right?
Yep. Okay. So based on filter area, I guess. Would be the
Yeah,
answer to
based
that.
on, well, the flow rate itself is based on the pump size and the filter, of course, the hollow fiber
Surface area.
numbers themselves. But we really attempted to make the scale down a proportion of our larger systems, right? So it is a very linear scale down model.
Yeah. I think just to show the broadness of that same question, like choosing between now that the ATF1 is there, like question came in, my scale up from an Amber system is a 2-liter bioreactor. Totally get it. Would you suggest an ATF1 or 2?
So Amber systems is like more of maybe a 250 mil. They have an Amber 250 that some customers have asked if the ATF1 can connect to. In terms of working volume, I think it is possible. It's more like the connection. How do you connect the ATF1 to that Amber? What is on the Amber that allows for that connection to be made? Is there a dip tube? What's on that dip tube? So these Amber bioreactors, I get a lot of questions about this. We don't have anyone who's really done this yet, since we just launched about a month ago. But that's to be seen. I think theoretically it can be done. Let's just see who's going to be doing it in the future. Yeah.
Oh, so I think they're basically saying, I'm with you. Like, I think they're in an Amber now, right? Their first
Mm-hmm.
screen is an Amber. Then they go up to a 2-liter. And the question was
Yep.
like, when they get to that 2-liter, is it an ATF? Is it the new ATF1 or is it an ATF2? It's kind of like,
Oh, okay, right. So
yeah,
at that 2-liter, I mean, it depends on what you're doing with if you have an Amber perfusion process. What are your parameters there? But 2 liters, if you really want the proper ATF scale, it would still be ATF1. If you look at ATF1 being used for a 2-liter bioreactor, that is about equivalent to an ATF10 being used for 1,000-liter. One ATF10 for
yeah,
1,000-liter. So it's really that proportion.
yeah. Okay. This is right in your wheelhouse because it's core to your responsibility. Can we schedule for on-site demos, right? That's
Yes,
an easy one for you.
when we can start traveling, yeah, on-site demos of us going there and doing a demo, that is possible. You have to speak with your bioprocess account, your local bioprocess account managers who bring the local FAS in, who kind of plan these demos for the ATF. We've been doing this during this whole COVID pandemic. We've been doing this kind of virtual. It's been challenging, but we've been able to do it with success. But hopefully, within the
Yeah.
next few months, we'll be able to travel more.
Okay. Do you have a process for that? I mean, so I think it's a really good question, right? Like, is on-site possible? Yes. Like, if on-site doesn't work for either party, like the bioprocess lab or ours, like, have you worked out a process for doing it without on-site support, like basically virtual support?
Yeah, we've done
Yeah.
virtual support, and so the customer, with all this planning, the customer orders the consumables necessary for that demo. We put in our system. The demo is sent over there. We make sure that all the parts are there. We make sure that the customer, beforehand, has all the utilities required for this demo, and then we schedule kind of maybe a 3-hour virtual, meeting where we have a camera on their side, and I have a camera on my side, and then we kind of look at each other and try to point at things, which can be challenging, but that's how we've been doing it.
Yeah. More ATF1, 2 questions and more Amber. When you said you get a lot of this,
Yeah.
I believe you now.
Yeah.
Let's try and get to how are the AT, because we're doing this real time, right? How is the ATF1 held? Okay, that seems straightforward. ATFU as a bulky holder would not fit into the Amber. And are you planning to come out with an off-the-shelf way to connect to an Amber 250? There's the Amber 250 again.
So the ATF1 does not come in the same type of stand that the ATF. Well, maybe you're talking about the single-use ATF2, which does have this kind of bulkier stand, really heavy stand. The ATF1 is usually just we have this kind of clamp onto a shelf, so it's really it doesn't take much footprint at all, and you can adjust the height so that it really matches up with where your head plate fitting is on that bioreactor.
And we have one last one from Carlos. Basically, how can I access the webinar recorded? I actually might take that one if I might take the last one.
Yeah, go ahead.
So
Go
all
ahead, Wes.
yeah, sorry. So all of our webinars are posted on the webpage, right? So you can always go to our webpage and go to resources and go to webinar. It's also available from the ETF page. Basically, you can go there, including this one and future ones will be, and they're also posted on YouTube and things like that. So really easy to find on the webpage, really easy to find on all our video sources, always posted afterwards. And then just to kind of plug the future, we will be talking about in combination with collaborators, including TCAN on the Opus robocolumns. If you're interested in accelerating process development with the small chromatography columns, join us on May 27th for the next episode 3 of the webinar series. All right. And I think that's a wrap. So I just like to say thank you again for taking 15 or 20 minutes out of your busy day to join Earl and myself. I'd like to thank Earl for taking time out and joining us for the Q&A and presenting. And hopefully we'll see you on episode 3 on May 27th.
Yeah.
Thank you. And
Thanks,
bye-bye.
everybody.
Yep.
Bye-bye.